Hello, CSEC scholars. This morning we're going to be doing simultaneous equations, solving two linear simultaneous equations. And we're going to be focusing on the method of elimination. So we did this last week as well, but this is one of those topics that students have issues with, and so it's always good to get as much practice as you can. We also have already done solving simultaneous equations using the method of substitution. So if you would like to know how to use that method, just go on the channel. You can search in the live videos, and you can also search in the Algebra playlist, and you will see how to solve simultaneous equations using the method of substitution, also using the method of elimination, as well as there are two other methods that we can use to solve simultaneous equations, and those are the method of matrices and the graphical method. So all of those methods have already been covered. This is just extra practice for us. And so we're going to be doing 6 questions now, six sample questions. I'm waiting for my scholars to log on, and then we're going to move right ahead. So to recap, for the method of elimination, so we had said last time we did elimination, I told you that you need to make sure that when you're doing math, it's always a good idea to look at the keywords being used and to get the definitions for them, because this will greatly help you in terms of understanding the concepts, understanding the methods. So we had said that elimination means to get rid of, to cancel out, to ignore for the time being, anything along those lines. So in the elimination method, what we do is we eliminate one of the variables. We get rid of one of the variables. We cancel out one of the variables, either the x or the y, or whichever letter it is that we're having in our equations. Remember, so in this case, we have 2 linear equations, and we also have 2 variables, an x and a y, or a w and a p, or a triangle and a square, whatever symbols are being used to represent the unknown numbers, which is what we want to solve for. So we eliminate one of the variables and then focus on the other one. And then when we have solved for the other one, we go back and plug that value into one of the original equations to solve for the variable that we have eliminated. So I'd also explained that in order to do that, what we do is we first of all look to see if we can go straight away and eliminate one of the variables. And we'd be able to do that if they have the same coefficient, or if they have the same digit but the signs are different, then we can either add or subtract in order to eliminate. Now, in this case, where we have number 1, 5x minus 2y is equal to 26, negative 5x plus 3y is equal to negative 29. If we look, we can see that the 5x and the negative 5x, they have different signs, but the digits are the same. So we can go ahead and eliminate those by adding. When the signs are different, we add in order to eliminate them. When the signs are the same, we would need to subtract. So we have a positive 5x and negative 5x. We're going to add the equations. So I would say add equation 1 and 2 So I always like to number my equations as well as to underline the original equations. When I add them, this gives 0. 5 plus -5 is 0. -2 plus -2y plus 3y, that gives y. And 26 plus -29 gives -3. So already we have solved for y. Y is -3. So now we go back to either one of the original equations and we're going to plug in -3 either here or here, wherever we see y. So all you need to do is identify which of the equations you're using. So I'm going to use the first equation, 5x minus 2y is equal to 26. And since we just found out that y is -3, so I'm going to plug in -3 where y is. So I'm going to have -2 and put a bracket and -3 and finish up the rest of the equation. All right, so let me fix this x here. It doesn't look good. Okay, so this is a x. So we just need to multiply the -2 times -3. So we would have 5x plus 6 is equal to 26. So we need to isolate the 5x by subtracting 6 from both sides, which would get rid of the 6 from the left. And it's going to give us 20 on the right. So 5x is equal to 20. Therefore, now we need to isolate the x by dividing both sides by 5. So x is equal to 20 divided by 5, which is 4. So for our solution set, then we have solved for both x and y. X is 4 and y is 3. And always when we solve our equations, we plug our values back into the original equation just to check and make sure. So if we're saying that for the solution set, x is 4 and y is -3, so plugging those in, 5 4s 20, -2 times -3 is 6, 20 plus 6 gives 26. But it's not enough to try them in one equation. You have to try them in both to make sure. -5 times 4 is -20. 3 times -3 is -9. -20 minus 9 is -29. And so we are correct for the first solution set. X is equal to 4, y is equal to -3. If you have any questions as we go along, don't hesitate to ask. Also, if you're working them out with me, just post your answers as well. You know, it's a way of building your confidence, and it's a way for us to compare how we are progressing. So that's the first one. So we're actually doing 6 problems for this session. Let's go on to problem number 2. And as usual, I'm going to be numbering my equation. So -x plus 6y is equal to -5. That's equation 1. And 7x minus 6y is equal to 35. That's equation 2. So again, we look and we see that we have a 6 and a -6. So we can add the equations to cancel out these. So if it was a +6 and another +6, we'd have to subtract them in order for it to be equal to 0, so we can eliminate it. If it was a -6 and another -6, we'd have to add them again subtract them. So negative 6 minus negative 6 is the same as negative 6 plus 6. Or 6 minus negative 6 is the same as 6 plus 6. So we have a positive 6, negative 6. When we add them, we get 0. Okay. So I was explaining that if this was a negative 6, we would subtract. It would be negative 6 minus negative 6, which is the same as negative 6 plus 6, which would be 0. So when the signs are the same, we subtract. And when the signs are different, we add in order to get 0 to eliminate. So if we're adding both equations, so negative x plus 7x, that would give 6x, and negative 5 plus 35 would give 30. So if 6x is 30, then x would be, dividing both sides by 6, x would be 5. All right, so we have solved for x, but remember, it's two variables. We can't just solve for x and think that we're finished. We now have to go solve for y. So we're going to plug in this value of x either here or here. So let's use the first equation. Always write back the equation that you're using. Don't just go bam and substitute it. Write back the equation. So that was a 6. So negative x plus 6y equals negative 5. And we're going to plug in the value of 5 where x is. So we'll have negative 5 plus 6y so 6y is equal to negative 5 plus 5, which is 0. So if 6y is equal to 0, then y must also be 0. So for the solution set, y is 0 and x is 5. And if we plug those in, so if we put 5 here and 0 here, multiply 6 times 0 is 0, and that's negative 5 will be left. And 6 times 0 is 0. 7 times 5 is 35. So that one checks out as well. So we move on to question number 3. So that's our first equation, 8x plus 9y is equal to negative 25. And our second equation, negative 4x minus 6y is equal to 14. Now, if we look at these equations, now this pair of equations, none of them have the same digits or the same coefficients. So we have to do an additional step now than the first two that we did. We're going to have to cross multiply the equations by the opposite coefficients in order to get the same coefficient or at least the same digits. So you can choose which pair. You can multiply this equation by 4 and this equation by 8, or this equation by 6 and this equation by 9. So you choose. So I'm going to multiply this equation by 4 and this equation by 8. And when I do that, I'm going to have 8 fours 32x and 9 fours 36y and negative 25 times 4 is negative 100. And when I multiply this equation by 8, I'd get negative 32x minus 24y 8 fours, 32, so that's 72. So now I have equation 3 and equation 4. Two new equations, but this time we do have the same digits, different signs, but the same digits. So the signs are different. That means we need to add the equations in order to eliminate. So adding equation 3 and equation 4. All right, so when we add them, then we know that that's going to be 0. We have eliminated the x. 36y plus negative 24y, that's going to give 12y. And negative 100 plus 72. All right, so let me retract because I think I'm doing something wrong here. All right, 8 4 is 32, 4 9 is 36, 4 times that is negative 100. Let me see if it was a 14 times 8. Oh, so this should have given, oh, this should be 112. Okay. Okay, so that should be 112. So it's it's negative 100 plus 112, and that gives 12. Sorry, negative 12. So y would be equal to 12 divided by 12. Which is 1. All right, so if we're going to plug in the value of 1, where y is, all right, so let me double check that I wrote off the correct thing. 8x, 9y, negative 25. I'll multiply that by 4, that by 8, negative 4x minus 6y, and we have 14. All right, so that's 36. That's 8 4 is 32. Oh. So how my scholar's not seeing that I'm writing the wrong thing here? Okay. You must help me and look and correct me if I'm wrong. All right, so we had negative 6y times 8. So what should that be? That should be 48, negative 48. Okay. All right, and 36 minus 48. So this one here should be negative 12. So negative 12y is equal to positive 12. That means y is equal to 12 divided by negative 12, which is negative 1. All right, so now that we see that y is negative 1, we're going to plug this value in either one of the equations. So let's use the smaller numbers. Negative 4x minus 6y is equal to 14. And we're going to plug in -1 where y is. So -4x minus 6 times -1 equals 14. And -6 times -1, that's going to give us a positive 6. So we're going to have -4x plus 6 is equal to 14. So -4x is equal to 14 minus 6, which is 8. Okay. -4x is equal to 8. So x is equal to 8 divided by -4, which is -2. So our solution set, x is -2, y is -1. So 8 times -2 is -16, 9 times -1 is -9, -16 minus 9 is -25. -4 times -2 is a positive 8, -6 times -1 is a positive 6, and 8 times 6 gives 14. So we're halfway there. We have another 3 questions to go. All right, so for this question, we saw that if we look at the 2 equations and none of the variables have the same coefficient, or at least the same digit but different signs, then we have to do an additional step, which is to cross multiply the equations by the corresponding coefficients. And in doing that, we'll end up with the same coefficients, or at least the same digits. And then we can continue. So what I'm going to do then, since the coefficients are not the same, I'm going to multiply equation 1 by 8 and equation 2 by 2. You could have also used the 9 and the 4, so you could have multiplied equation 1 by 4 and equation 2 by 9. So I'm going to multiply equation 1 by the 8 and equation 2 by 2, these corresponding coefficients. So if I'm multiplying everything in equation 1 by 8, I'm going to end up with 8 9 72x plus 8 2 16y is equal to, so 73 times 8 is 584. And that is equation 3. Multiplying everything in equation 2 by 2, we'd end up with 2 4s 8x, 2 8s 16y, and 2 times 68, that's 136. Now this time when we look, we see that it's a positive 16y and a positive 16y. So the signs are the same. When the signs are the same, we subtract in order to eliminate. So we're going to subtract equation 4 from equation 3. So we're taking the bottom numbers from the top numbers. And when we do that, so it's going to be 72 minus 8, which is 64. And then we know the 16y minus 16y, that's going to be eliminated. And 584 minus 136, that's 448. And if we divide that by the 64, we get 7. So x will be equal to 448 divided by 64, which is 7. So now we're going to plug in this value of 7 where x is in any one of the equations. So let's use the second equation, 4x plus 8y equals 68. So if x is 7, 4 times 7 plus 8y equals 68. And 4 sevens are 28. So then 8y would be equal to 68 minus 28, which is 40. So 8y is equal to 40. Therefore, y would be equal to 40 divided by 8, which is 5. Okay, so the solution set x is 7 and y is 5. So 9, 7, 63, 2 5s 10, 63 plus 10 is 73. 4 sevens 28, 8 5s 40, 28 plus 40 is 68. And that's how you plug back your values each time you solve, whether it's a single solution or a set of solutions. Plug the values back into the original equations to make sure that they add up. All right, so looking at number 5, we do have variables with the same coefficient. So we have negative 3x minus y is equal to 15, 5x minus y is equal to negative 33. So they both have a negative y, same signs. So we're going to subtract the equations in order to eliminate. So subtracting equation 2 from 1, so it would be negative 3x minus 5x, and that will give 8x. Negative y minus negative y would cancel out the y. And 15 minus negative 33 would be positive 48. This should be a negative 8x. So x is equal to 48 divided by negative 8, which is negative 6. All right, so we have solved a half of our equation. X is negative 6. Now we need to plug that into one of the other equations to solve for y. So I'm going to use the first equation, so I'm writing it. Negative 3x minus y is equal to 15. So if x is negative 6, it will be negative 3 times negative 6 minus y is equal to 15. Negative 3 times negative 6 is positive 18. So 18 minus 15 would give us y. And that is 3. So we're saying that for the solution set, x is negative 6 and y is positive 3. Plug in those values into the original equations. Negative 3 times negative 6 is positive 18, minus 3, that gives 15. 5 times negative 6 is negative 30, minus 3 is negative 33. So that one checks out as well. and we have 1 to go. All right, so Ngozi is saying, I've always wondered, is it optional to solve y first, then x, and vice versa? Or does it have something to do with the numbers themselves? It's optional, Ngozi. You choose which one you want to solve for first. In this case, in number 5's case, where the coefficients are already the same, since that was given to us as is, then in this case we would go ahead and eliminate the y because that's easier to do, and then we'd solve for x first in that case. But you still could have decided to ignore that and multiply the equations by whichever cross coefficients you want and still solve for the x. You could choose to use substitution method and solve for the x first. So it's up to you really, but always I would encourage you to look at the equation given and see if there are shortcuts, see if you can save yourself some work. In this case, you definitely could save yourself some work, right? Because it's given to you on a platter. The two of them have the same coefficient, just simply subtracting them will eliminate it. So where you see that, take advantage of that. So number 6, 8x plus 7y is equal to 12. That's our first equation. Negative 2x minus 3y is equal to 2. That is our second equation. And looking at them, we see that none of the coefficients are the same. So we're going to cross multiply the coefficients. So I'm going to multiply equation 1 by 3 and equation 2 by 7. And in doing so, I'm going to end up with 24x plus 21y is equal to 36. And that is equation 3. When I multiply equation 2 by 7, I'm going to get negative 14x minus 21y is equal to 14. And that is equation 4. So now we have 21, positive 21y, negative 21y. So we know that we're going to need to add the equations. So we're adding equation 3 and equation 4. And when we add them, 24x plus negative 14x, that gives 10x. 21y plus negative 21y gives 0, so that's eliminated. And 36 plus 14 gives 50. Therefore, if 10x is 50, x is equal to 50 divided by 10. So x is equal to 5. So now that we're halfway there, we have solved for x. We need to plug this value back in one of the other equations to get y. The second equation has smaller numbers. The first equation has all positive numbers. Whichever one you choose, whichever one you find more convenient to use. If we work with this one, we end up with bigger numbers, which it's easier to work with smaller numbers. But these ones have negatives, which some persons have a problem with. I'm going to go with equation 2. So that's negative 2x minus 3y is equal to 2. So I'm plugging in 5 where the x is, put a bracket and put 5. And it means negative 2 times 5. Now that's what we're going to do. Negative 2 times 5 is negative 10. All right, so negative 10 minus 2 is equal to 3y, and that's negative 12. So y would be equal to negative 12 divided by 3. So y is negative 4. Our solution set is x is 5 and y is negative 4. So that's an equal sign. So let's plug those in and see if they add up. So if x is 5 and y is negative 4, 8 5s 40, and 7 times negative 4 is negative 28. 40 minus 28 is 12. Negative 2 times 5 is negative 10. Negative 3 times negative 4 is positive 12. Negative 10 minus 12 does give 2. So that means our solution set is indeed the solution set. And our answers are correct. So that's the 6 problems for today. So we have done all of the methods for solving simultaneous equations. The algebra method, we have looked at substitution and we have looked at elimination. The matrices method we've done and the graphical method we've done. Any one of these that you encounter in the exam, if you're asked specifically to solve the simultaneous equations using that method, because sometimes you are told solve this pair of equations using the elimination method, solve them using the substitution method, solve them using a graphical method, solve them using the matrix method. Any way they ask you, you should be able to do it. If you are not told specifically what to do, then it's all up to you. It's all up to you to decide which method works best for you, you're more comfortable with, then by all means go for that. All right, so that's it for solving simultaneous equations using the method of elimination.